Welcome to the Deep Dive. We're here to unpack the fascinating, sometimes really unexpected ways AI is, well, quietly changing industries. When you think AI, maybe picture self-driving cars, stuff like that, or streaming recommendations. But it's actually making critical inroads in fields where precision, safety, and just basic human trust are absolutely paramount. Today, we're taking a deep dive into something very specific but really important. AI in small, general aviation GA repair shops. And maybe more importantly, how do these shops make sure their AI processes are, completely bulletproof, especially when facing audits, for regulators or even customers? Our mission today is to demystify what it really takes for an AI-powered maintenance shop to be not just compliant, but, well, genuinely trustworthy. It's about understanding the essentials, the best practices for standing up to that kind of intense scrutiny.
Exactly. And this isn't just theory. We're basing this deep dive on practical guidance for these shops. We're drawing directly from established FAA guidelines like AC 12078B, which is all about electronic records, and also the NIST AI Risk Management Framework. That's a key tool for managing AI risks pretty much everywhere now.
Right. So the goal is for you, listening, to walk away with a crystal clear idea of what makes an AI-powered shop truly audit-ready. Let's get into it.
Yeah.
Okay, so when we talk about AI actually, entering the hangar, what kind of specific tools are we seeing in these smaller GA repair shops? What does that look like on the ground?
Well, it's interesting how diverse it is already. For an audit, you absolutely need clear documentation on which tools are being used. So, for example, we're seeing AI used for predictive maintenance alerts, flagging a potential engine issue before it becomes critical.
Ah, okay. That sounds huge for safety.
It is hugely impactful, but it's also used for more operational tasks like parts demand forecasting, making sure shops have the components they need right when they need them, cuts down on aircraft downtime.
Makes sense.
And beyond just what tools, shops need to clearly define the AI's role. Is it mainly decision support? Giving data to a mechanic who makes the final call? Or is it moving more towards automation, taking some actions directly? And each tool has to map to a specific function, maintenance scheduling maybe, or calculating a component failure risk score based on flight history.
Okay, so the AI flags something or makes a recommendation. What's the absolute next step? How do shops make sure that, human oversight is still central and that every single thing is logged meticulously, that a human is definitely still in charge?
Right. This gets to the absolute foundation, maintaining what we call AI-linked maintenance records. It's critical. Any insight from an AI that actually triggers maintenance, it has to be logged with incredible precision. This isn't just good housekeeping. It's about creating an unbroken chain of evidence.
An evidence chain, right?
Yeah. Timestamps linking the insight directly to the aircraft ID, the tail number, and documenting the final inspection outcome. This lines up directly with 14 CFR Part 43.9, that's the basic maintenance record rule, and also AC 12078B on digital records and signature integrity.
Okay.
And it goes further. Shops need really robust traceability and human-in-the-loop controls. This means a full audit trail for every single AI recommendation. It has to clearly show where the mechanic signed off, or just as vital, where they decided to override the AI's suggestion.
Ah, the override is important too.
Absolutely. The log needs details,
Yeah.
the input data the AI used, maybe sensor history, past repairs, stuff like that. Then the specific AI output, like predicts alternator wear in less than 10 flight hours. And then, crucially, the human validation. Mechanics notes their A&P signature.
A&P, that's the Certified Airframe and Power Plant Mechanic.
That's the one. Holds the FAA certification. Their sign-off is key.
That makes perfect sense. Okay, so we've got the tools, the super detailed records.
Yeah.
But in aviation, that signature isn't just a scribble, right? What does this mean for the really strict rules around electronic signatures?
You're absolutely right. Electronic signature compliance in aviation is incredibly strict. AC 12078B lays it out very clearly. We're not talking simple mouse clicks here. These digital signatures have to be uniquely attributable. One person, one signature, no sharing.
Okay, unique.
They have to be tamper evident, meaning if anything changes, even a tiny bit, it flags as invalid, like a broken digital seal. And they must clearly show the time, the signer's intent that they meant to sign, and their unique ID.
Wow, okay, that's thorough.
It has to be. For safety, accountability, legal validity. And one more thing. If a shop operates under certain FAA rules, like Part 91K for fractional ownership, Part 135 for charters, or Part 145 for certified repair stations, they must use FAA-accepted electronic signature systems. No wiggle room there.
Got it. So AI is powerful, getting better all the time, but it's not perfect, right? Not infallible. What happens if there's a bad recommendation? Or maybe the AI just has known limits. How do shops handle that in a way an auditor accepts.
Yeah, good point. This is where AI risk governance logs come in. And this lines it perfectly with the NIST AI risk management framework. Shops need to proactively keep detailed logs, documenting any known limitations of their AI tools.
Okay, so they admit the limitations up front.
Exactly. But it's more than that. If there's an incident, an erroneous recommendation from the AI, that must be logged too. And crucially, the log also needs to detail the fix, the mitigation actions. Was it patching the software, retraining the AI model with better data, or maybe even just switching back to manual methods for a bit until the AI is corrected?
Ah, like a feedback loop.
Precisely. Think of it as building a lessons learned database for the AI itself. Track it, fix it, prevent it from happening again. That's what auditors want to see.
That proactive approach sounds vital. Okay, so let's pull all these pieces together. Defining the AI, the records, the risk management.
Mm-hmm.
What does a shop actually need to have ready? Like in a binder, physical or digital, for that FAA auditor, what are they looking for?
Yeah, for an FAA auditor, a well-organized FAA readiness binder is essential, no question. This binder needs the shop's standard operating procedures, their SOPs. And these need to clearly show how AI fits into the daily maintenance workflow.
So it's integrated, not just bolted on.
Right. And if any AI tools touch regulated areas, they need copies of relevant OpSpecs operating specifications, or LOAs, letters of authorization. A really critical piece is the backup and archival policy for all electronic records. Following AC 12078B guidance again ensures data lasts and is accessible even years later.
Long-term thinking.
Definitely. And finally, clear proof of the mechanic's A&P certification and their ongoing training, especially training related to using these new AI tools safely and effectively.
Okay, so that covers the regulators. But what about customers? They obviously care deeply about safety. Do they want to know how AI is being used on their aircraft? What's needed for that customer-facing transparency?
That's a really important point, and it's growing. Customers, especially, say, fleet operators or charter clients who might do their own audits, they want reassurance. So shops need a clear documentation explaining exactly how predictive AI is used in maintaining their aircraft.
Traceability for the customer, too.
Yes, offering traceable reports tied directly to the aircraft's maintenance logs so the customer can see the path from an AI insight to the actual work done. And most importantly, shops have to clearly show how human oversight is built in at every step, assuring customers that AI is a tool enhancing safety and efficiency, but it's not replacing that crucial human judgment and skill of a certified mechanic.
That really was a comprehensive deep dive. Wow. Into this surprisingly rigorous world of auditing AI and aviation maintenance. We went from defining the AI scope through meticulous records, human oversight, managing risks, and finally, that critical transparency for regulators and customers.
Yeah, and if we zoom out a bit, the key takeaways for you, the listener, are pretty clear. Bringing AI into safety-critical fields like aviation, it demands robust documentation, clear human accountability always, proactively identifying risks, and just unwavering transparency. Those are really the pillars for building trust and ensuring compliance as AI becomes more common.
Absolutely. Which leads to a final thought. As AI gets woven deeper into all sorts of critical infrastructure, transportation, energy grids, healthcare, how might these tough principles of auditability and transparency, the ones being honed right now in aviation, how might they apply to other industries? Industries you rely on every single day. Something to think about.